Alright, so in this problem, I have x to the power of 4 is equal to 4. So to solve this, I'm going to first start by subtracting 4 on both sides. So then these two cancel out, and I get x to the power of 4 minus 4 is equal to 0. Now, I'm going to rewrite 4 here as 2 squared. So now I have x to the power of 4 minus 2 squared is equal to 0. And I'm going to write x to the power of 4 as x to the power of 2 times 2. So I have x to the power of 2 times 2 minus 2 squared is equal to 0. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, I can rewrite that as x to the power of 2 to the power of 2 minus 2 squared is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 2. So I have x squared plus 2 times x squared minus 2 is equal to 0. Now, this gives me two equations. I get x squared plus 2 is equal to 0, and I also get x squared minus 2 is equal to 0. So to start, for x squared plus 2 equals 0, I'm going to subtract 2 on both sides. So then these two cancel out, and I'm left with x squared is equal to 0 minus 2, which is negative 2. Now I'm going to take the square root on both sides. So I have the square root of x squared is equal to the square root of negative 2. Square root of x squared is obviously x, so I have x is equal to positive or negative square root of negative 2. And the square root of negative 2, I can rewrite this as the square root of 2 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So I have x is equal to positive or negative the square root of 2 I. Now for this one, I have x squared minus 2 equals 0. So this time I'm going to add 2 on both sides. These two cancel out. And I get x squared is equal to 2. And now I'm going to take the square root on both sides. Square root of x squared is x. So I get x is equal to positive or negative square root of 2. So now to check, that is actually, those are our 4 solutions to this problem. Alright, so in this problem, I have x to the power of 21 plus x to the power of 14 is equal to 36. So I'm first going to rewrite this as x to the power of 7 times 3 plus x to the power of 7 times 2 is equal to 36. Now, I'm going to put this as x to the power of 7 to the power of 3 plus x to the power of 7 to the power of 2 is equal to 36. Now I can let x to the power of 7 equal to the variable y. So now I have y to the power of 3 plus y squared is equal to 36. Now if I subtract 36 on both sides, these two cancel out, and I get y to the power of 3 plus y squared minus 36 is equal to 0. Now negative 36, I can rewrite this as negative 27 minus 9. And now I can rewrite this as y to the power of 3 minus 3 to the power of 3 plus y squared minus 3 squared is equal to 0. So if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, I can rewrite y to the power of 3 minus 3 to the power of 3 as y minus 3 times y squared plus 3 squared plus 3y, plus I can rewrite y squared minus 3 squared as y plus 3 times y minus 3, and this is equal to 0. Now if I factor out y minus 3, I get y minus 3 times y squared plus 9 plus 3y plus y plus 3. This is equal to 0. And this is simplifies into y minus 3 times y squared plus 4y plus 12 is equal to 0. So this gives me two equations. Y minus 3 is equal to 0, which means y equals 3. This is one solution. And y squared plus 4y plus 12 is equal to 0. So to solve this, we have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. And I'm not going to waste your time actually plugging them in, but if you do, you end up getting that it's less than 0, so this won't work out. So y equals 3 is my only solution to this equation. Now remember how we let x to the power of 7 equal y. So now I have x to the power of 7 equal 3, meaning x is equal to the 7th root of 3. Alright, so in this problem, I have x to the power of 6 minus x to the power of 3 is equal to 2. So I'm going to first start by subtracting 2 on both sides. So now I have x to the power of 6 minus x to the power of 3 minus 2 is equal to 0. Now I'm going to rewrite x to the power of 6 as x to the power of 3 squared. Now I have this minus x to the power of 3 minus 2 is equal to 0. Now I'm going to let x to the power of 3 equal to the variable y. So now if I substitute in x to the power of 3 for y, or sorry, y for x to the power of 3, I get y squared minus y minus 2 is equal to 0. So now I'm going to factor this by rewriting this as y squared minus 2y plus y minus 2 is equal to 0. Now I'm going to factor by grouping, so I have y times y minus 2 plus 1 times y minus 2 is equal to 0. So now if I factor out y minus 2, I get y minus 2 times y plus 1 is equal to 0. So this gives me two equations. Y minus 2 is equal to 0 and y plus 1 is equal to 0. For y minus 2 equals 0, y equals 2, and for y plus 1 equals 0, y equals negative 1. Now remember how we let x to the power of 3 equal y. So now I have x to the power of 3 is equal to 2, and x to the power of 3 is equal to negative 1. So for x to the power of 3 equals 2, I can simply take the cube root on both sides. So now I have x is equal to the cube root of 2. And for x to the power of 3 equals negative 1, again, I'm going to take the cube root on both sides, so I get x is equal to the cube root of negative 1, and the cube root of negative 1 is simply negative 1. So I have x is equal to negative 1. So these are my two solutions to this problem. Alright, so in this video, I'm solving the equation x to the power of 3 is equal to 3 to the power of 3. So to solve this, I'm going to first start by subtracting 3 to the power of 3 on both sides. So now I get x to the power of 3 minus 3 to the power of 3 is equal to 0. Now from here, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So this turns into x minus 3 times x squared plus 3x plus 9 is equal to 0. So now from here I get two equations. I get x minus 3 equals 0, and x squared plus 3x plus 9 is equal to 0. So obviously for x minus 3 equals 0, x is equal to 3. So this is one solution. And now for x squared plus 3x plus 9 equals 0, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So this turns into negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times a, which is 1, times c, which is 9, all over 2a, so 2 times 1. And this turns into negative 3 plus or minus the square root of 9 minus 36 over 2, which is equal to negative 3 plus or minus the square root of negative 27 over 2, which is equal to negative 3 plus or minus the square root of 27 times the square root of negative 1 over 2. Now, 27 is the same thing as 9 times 3. And the square root of 9 is 3, so I get x is equal to negative 3 plus or minus 3 root 3. And the square root of negative 1 is actually equal to the imaginary number I. So these are two more solutions to this equation.